This is Geometry, Semester 2, and this is the 7th unit called Conics. I'll explain that in a minute, if you don't know what it is already. And this is the first lesson called Circle Practice. So this is on creatormath.com. It's under the Geometry tab. You might have to type in to Google creatormath.weebly.com to find the site. Here are the instructions on this set of problems. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So make sure you know where the notes are. Most of you do, but just to, I almost review it regularly here. All right, so here I am. Well, this is quadratics. Let's go out of this. Let's go back to the home page of creatormath.com. It looks like this. And that's how you know you're at the right place, because you'll see my goofy face there, and then you'll be like, okay, I'm on the right site. All the comp book stuff you guys know is on the home page, all the video links to how to get a great grade in the class, how to do your composition book, etc., what goes on all the pages of the comp book, when the comp book is due. There are the comp book dates. Of course, it's going to be different by the time you're watching this, so follow the actual website dates. It tells you all about what goes on the cover of the comp book, etc. Let's go straight to the Geometry tab, because that's where the notes are we're looking at right now. Pass by the vocabulary stuff, which shows up first. Get to Geometry, Semester 2, Table of Contents. This, by the way, is all to be written onto page 2 through 6 of your composition book. Each one of these is a unit. I see trigonometry, I see special right triangles, and let's see, volume, conditional probability, circles, angles, and arcs, surface area. And this one is conics, right? Conics is the 7th unit, and each one of these is a lesson. There's 5 lessons within it. We're on the first one, circle. So as of this writing, the notes for this go on page 127, 128. Don't follow this video for the actual pages, though. Go to this table of contents on the website to verify its current page numbers. Here's notes. If I click that, it opens up an image of either the board or my notes. Let it load, and there you go. These are the notes you're going to copy into your pages in the composition book, and that will help you do the problems we're about to do right now. And I'll keep those open because there's things like equation of a circle, x minus h, contents squared, plus y minus k, contents squared, equals r squared. We're going to use that right now, where the center is hk, and r is the radius, right? We're going to go over that right now. There's some examples here, explaining where the center of the circle is, what r is, squared, etc. Don't forget vocabulary. All that goes in your comp book, as well as some problems that go into your composition book. So with that said, let's turn to the problems we have to do for this lesson. So, conic shapes. Conic shapes are those produced by slicing a plane through a double cone, which is point-to-point shape or three-dimensional shape. So here we have, let's try to draw over this one. Here we have a cone, right? This is a cone here, and point-to-point is another cone drawn up against it. Then if you can see here, this shaded part, there's a plane which slices through these two cones like this. And as it slices through, the shape it makes is here, and here. This shape is called a hyperbola. We spell it hyperbola. We say it hyperbola. You'll see the other one, if you slice through at an angle here, notice the angle of this plane, we get, what's commonly called an oval, but now that you're in geometry, you're calling it an ellipse. If you cut through flat through this cone, and we look at it from this side, we get a circle. So you got different shapes here. If we cut just through one of the cones this way, a little bit like a hyperbola, but it's just a single unit and it's a parabola, right? So in geometry, we think this is fascinating because we get 1, 2, 3, 4 different types of shapes. We get a hyperbola, ellipse, circle, and parabola. So this question is the setup for the whole conics unit. And this is what we're looking at through all these. We're going to look at individually hyperbola, ellipse, circle. This first one deals with circles. So a double cone attached end to end. What does this say? Conic shapes, which include the circle, ellipse, hyperbola, and parabola, are produced from what figure shown in the diagram below? This is called, to me, right, there's a little bit more sophisticated names, but let's just go with a double cone attached end to end for the moment. All right? and it's the shape that produces our conic shapes. So some other options are here: cylinder, no it's not a cylinder; pyramid, it's not a cylinder. And then the idea of an hourglass, right? I don't know if you know what an hourglass is. That's, you've seen the sands through the hourglass. That does look a little bit like a double cone, but it's not. An hourglass looks more like this, and it's got a small gap through which, you know, there's sand in the hourglass, and the sand passes through, right? And in the old days being before we had clocks and things to measure time, we would measure out time using a sand through an hourglass, and you'd put enough sand in there to give you certain times. So you could turn over the hourglass. Even now, if you have an egg timer in the kitchen, it's got sand in it, you turn it over, maybe it's a 60-second timer, right? But you could have an hourglass with sand in it to do all kinds of different times, an hour, or I imagine more. I actually don't know beyond the hour, but okay. So let's keep going. If a double cone is cut by a plane, as in the figure below. So a plane is a perfectly flat surface. It's infinitely thin, and it extends in all directions forever. We show it sort of in a three-dimensional angle like this, and it cuts. As it cuts through this thing, you cut it right in half, and to look at it sideways, you get a circle. Right? So that's one of the shapes. And I imagine they're going to go through all the shapes now. Nope, we're going to go right into a circle. So, which of the following is an equation of a circle? So, for an equation of a circle, we have x minus h squared plus y minus k squared equals radius squared. And we just looked at that in the notes. We're going to explain a little bit more as we go. What we said was h comma k is the center. All right, so we're going to see that. That's in the notes. And we said r stands for radius, which is the center to the circle distance. And there's some other misleads here. These are all wrong, just misleading you to try something else. Go with this one. Now, here's what it allows us to do. It says, maybe I should keep both in here. Let's keep both in here. So it says, which equation matches this graph? So first things first, let's look at where the center of the circle is. The center of the circle is out on the x2, comma, down on the y, -3, so -3, put it in parentheses. This is a coordinate location of the center. Then we also have a radius to this thing, and that's from the center to the side. The question is, how long is this radius? Well, since we're right at the center and it started at the side, it looks like the r equals 2 here. We don't have any units, but we can now use this equation of a circle, x minus h squared plus y minus k squared equals r squared. And we can plug this in. So if this is h and this is k, we're going to put in a 2 here, so x minus 2. Notice the minus is part of the formula. Plus y minus. Minus is part of the formula. What's k? K is a -3, so let's put that in a parentheses. Squared equals, r in this case is 2. 2 squared. So x minus 2 squared, y minus a -3, we could write this y plus 3 squared and just rewrite this stuff around it and make this 4. So what do we have here? X minus 2 squared plus y plus 3 squared equals 4. This is the equation of a circle. And you're going to ask, what does that mean, right? What in the world does this mean? So let's go to Desmos really quickly. Let's delete out some of these other things. And let's see what happens if we, a little bit, let's try to put this equation into Desmos and see what happens, right? Let's take parentheses, x minus 2. And I want you to try this. This is an important part of the assignment. We've got a parabola so far. That's kind of interesting. Plus, but now we're putting in the y plus 3, y plus 3, parentheses, squared. That's part of the equation so far. We need an equals here. Equals 4. And look at this. It draws for us what this represents. This equation draws a circle. So this is called the equation of a circle. And notice that these two line up with where we said the center was. It's 2 over minus 3. These change signs because of the zero product rule, right? So just to remind us, that means you take x minus 2 here, and you say equals 0. Add 2 to both sides to solve for x, and x is going to be equal to 2. That's how we get x equals 2 here. Check. And if you did the same thing, put this equal to 0 and solve, we would have y equals minus 3, which would be check. Fair enough? Let's keep going. Okay, and we can play with this equation. We'll do it for the different problems, and we'll see the circle change on Desmos. All right, which matches? So let's start with radius. Right? We know the equation of a circle ends in r squared. The radius of this thing from center to side looks like is 1, 2, 3, 4, 5. I'm checking the scale. It's 1. So if r equals 1, 1 squared is 1. So even if I look at my answer choices, I already know what the answer is. Let's confirm it. Let's find the center. The center is 1, 2, 3. So you got a 3, comma, and minus 3. Minus 2, excuse me. This is down 1, 2. So it's going to be x minus 3, because remember the formula has a minus in it. X minus h squared plus y minus k squared equals r squared. This is the formula we're following every time. Since it's got a minus in it, h is a 3, so you have minus 3. And that helps us reverse it back to where we were. That allows this to then work when we go in the other direction. So this has to be a minus in the original equation. And sure enough, it is, because we tried it here and we proved that this works. Let's try it in this case. Let's see if we can redraw this circle. Let's go right here. We're just going to change this to a minus 3. We're going to change this to a plus 2. And we're going to change the radius to a 1, not a 4. And there you go. Here's the little circle we have right here. I know the scale and things can be changed, so your eye is kind of like, doesn't look exactly the same. No, that's because the scale it's drawing at's a little bit different, the one on the screen versus the one drawn on the paper. So which equation matches? We're looking for two things. We're looking for the r. R equals what? Well, r starts here, right? And it goes out to here. So it looks like 1, 2, 3, 4, 5. R looks like 5. And the location of this thing is back on the x, 1, 2, 3, so negative 3 on the x, and down 5 on the y, so negative 3, 5. So it looks like we're going to have x plus 3 squared. We're going to have y plus 5 squared. Remember, there's a minus in the formula, so it's going to reverse both of these two pluses. And then we have 5 times 5 for r squared, or 25. And with that, on and on we go. So let's check radius first. Where are we going from? It looks like we're going from a negative 5 here to a negative 2. So this is 1, 2, 3. Radius equals 3. We're looking for a 9 when we square it. We already know this is the answer because it's the only one with a 9. And they could have made these problems a lot harder by making the equations very close, but they're kind of walking us through this gently. Let's find this center. This center is back minus 5 on the x, and it's down here at negative 6 on the y. So we're expecting x plus 5 squared, y plus 6 squared. Check. And again, the question is, why do those signs reverse? Because there's a negative in the actual equation of the circle. All right, which matches? Let's find the radius first. We're going from here to here, which looks like here and here. It looks like 1, 2, 3, 4, 5, 6, 7. Looks like r equals 7. The location of this point is out 1 on the x and up 4. So 1 comma 4. And remember the minus in the equation, so we're looking for x minus 1 squared. X minus 1 squared. And we're looking for y minus 4 squared. Y minus 4 squared equals 7 times 7 is 49. And that's back to just you're following this equation, x minus h squared plus y minus k squared equals r squared, where h comma k is the center and r is the radius. All right, and that's just from our notes and what we did. And even if we come back here and just do one last check, we have a x minus 1, so let's make this a minus 1. We have a minus 4 here, so let's have a minus here. And we have 49 for that radius. That's a larger circle than what we've got here. Let's put in 49. There we go. And you can move around your Desmos to see where this is, to see where the center is. Does it show me the center? Okay. Sorry about that. Like Grand Central Station around here. All right, so just make sure you're matching up the correct unit and lesson, right? This is Geometry Semester 2. It's the unit on Conics, number 7, and it's the lesson number 1 on the circle, and it's creatormath.com under the Geometry tab. Hope this helps.